Hey guys, welcome to question MM240 of the Maths Methods Fortify study guide. We've got this function f of x equals log e of x plus 1 minus 1 from -1 to infinity. Now, part A is a 3-mark question and we're going to have to sketch this graph. So the question asks us, sketch the graph of y equals f of x and label any axis intercepts and asymptotes. Awesome. So first things first is we're going to need x-intercept, y-intercept, and an asymptote, all right? So in a log graph, whatever's inside of our bracket, that determines what our asymptote is, all right? So because this is x plus 1, we're actually going to have an asymptote at x equals -1, all right? So it's like your opposite of whatever number's here, because it's like whatever x has to equal to make this inside equal 0. So it's like x plus 1 equals 0, which means x is equal to -1. So that's our equation of our asymptote, which means we have an asymptote at -1. So like this. Awesome. So that's our first thing. Second thing are our x and y intercepts. So how do we work out x and y intercepts? Well, we let y and x equal 0. So for x intercept, y equals 0. So 0 equals log e of x plus 1 minus 1. 1 equals log e x plus 1. So e to the power of 1 equals x plus 1. Therefore, x is equal to e minus 1. Awesome. So because e is roughly, actually, let's just write this down. So our coordinate is going to be e take 1. And we'll just do our y-intercept before we figure out where that other one is. So the y-intercept occurs when x equals 0, which means that f of 0 is equal to log e of 0 plus 1 minus 1. Log e of 1 is 0, which means that our intercept is going to be -1. So 0, -1. Awesome. So we know that we've got an intercept at 0, -1, and e take 1, 0. Now e is about 2.7, which means that our intercept is going to be at about 1.7. So let's call it maybe here. So now we can sketch it, right? So we've got our asymptote, we've got our y-intercept, we've got our x-intercept. We know this is a positive log graph, so it's going to have a general shape like this. So it's just going to come up from our asymptote, come through here, and travel along like that. Awesome. So that's it. Now we just need to label our intercepts. So e take 1, 0, and this is 0, -1, and our equation for this asymptote is x equals -1. And that's it. So that's 3 marks. So whenever you're drawing graphs, it's almost like they give you 3 marks to start with, and then anything you don't include, they take marks off. So just include all of this. It's hard to tell exactly where the marks are given, but just include all of it and you'll be fine. So let's move on to part BI. Part BI is a 1-mark question. Part BI. And it asks us to find the rule for the gradient function f dash of x. Awesome. So we know that, I'm just going to rewrite this, we know that f of x is equal to log e of x plus 1 minus 1. And the gradient of a log is equal to the derivative of this over this, right? So f dash of x is equal to the derivative of x plus 1, which is 1, over whatever's inside this bracket, so x plus 1. Now this minus 1 just turns to 0, so we don't have anything else there. This is our gradient function, f dash of x, and that's our first and final mark for this question. Let's move on to part BII. Part BII is a 3-mark question, and we're asked to find the equation of the tangent t of x to the graph of f of x at any point p f of p. Awesome. So first things first is to always recognize with these sort of questions that for an equation of a tangent, we're going to need a gradient and a y-intercept, right? So I always like to use our y minus y1 equals m outside of x take x1 formula, because that's the easiest way to find the equation of a tangent. So we're going to need our gradient, and we're going to need a point that we can sub into this equation. So let's start with our gradient. Well, in the previous question, we just found that f dash of x is equal to 1 over x plus 1, which means that at point P, f of p, our gradient is going to be f dash of p, right? So 1 over p plus 1. So this is our gradient. M equals 1 over p plus 1. This is our first thing. And our first mark comes here, actually. Our second mark comes when we sub in our point. Okay, so we know that the point occurs at p f of p, which means that we have p. Now, f of x is log e of x plus 1 minus 1, which means that f of p is going to be log e of p plus 1 minus 1. Awesome. Which means that we can actually sub this point into this equation as well as this gradient, and that'll give us our answer. So y minus log e of p plus 1 minus 1 equals m, which is 1 on p plus 1, outside of x minus p. Awesome. This is our second mark. So subbing in those is our second mark. And now we can kind of evaluate this and get an actual equation. So we need an equation for t of x, which means we're going to need to get y by itself. So in that case, we're going to get y. I'm just going to expand this bracket out first. So y take log e of p plus 1, plus 1, right, because we have minus negative 1, equals x take p times 1 on p plus 1. So we can get x take p over p plus 1. Right, so I'll just times that to the top there. And then from here, we can get y by itself and say that y is equal to x take p over p plus 1 plus log e of p plus 1 minus 1. Awesome. But we're not done yet, because we need to say, therefore, t of x, because t of x is what we're looking for, equals x take p plus, over p plus 1 plus log e of p plus 1 take 1. And that's our third and final mark and our final answer for part BII. Always, always, always with these questions, guys, you're going to have a gradient and a point, right? So you're going to have the gradient which is 1 on p plus 1. So we find that using the gradient function. And then we're going to find a point using the point p. So that's it for that question. Let's move on to part BIII. Part BIII is a little bit of a tricky one. It's kind of a weird concept. And it is 2 marks. And it says, find the range of values of p for which t of x equals 0, where x is greater than or equal to 0, corrected 2 decimal places. All right, awesome. So this is kind of hard to explain, but I'll do my best. So if t of x equals 0, what we're really talking about there is our y value equaling 0 for the tangent, which means that the tangent is crossing the x-axis, right? So the x-intercept is where t of x equals 0, but we're saying where x is greater than or equal to 0. So what we're saying is the tangent is going to be crossing somewhere in between here, right? Our tangent's never going to be able to cross over here because it's the nature of the tangent. It's always going to kind of like be like this. It's kind of going to swing up like that, depending on which x value it's at or which p value. So we're looking for the values of p for which the tangent passes through this little area here, okay? So the thing is, we're going to have a tangent that comes, let's say, something like this. It's going to come up through there, because if it's any further down here, for argument's sake here, the tangent would be steeper, and so it would come through here, which is not the place that we want, right? We only want the tangent that goes between these two areas here. So it starts off here, starting at 0, and then it's gonna, as we move the tangent up, we increase our p value, which is, again, our x value. The tangent's gonna increase like this, so it's still intersecting somewhere here. Then it's gonna come up, come up, come up, and it's eventually gonna hit a point somewhere here where it passes through the origin again, right? So it's kind of like gone up like this, and it's kept kind of being a tangent, and it's still on this section, but as soon as it hits 0 on our left side over here, that's the lowest value of p that we can possibly have, and then over this side, the highest value of p that we can possibly have is when it again hits that 0 point there. So what that means is our tangent equation is going to have to equal 0, right? Because t of x equals 0, which means that we need to find the points of p. So here there's a p value, here there's a p value, And we're going to need to find these p-values for which this occurs, right? So we know that the intercept occurs at y equals 0. So 0 equals our tangent, right? So x minus p. Actually, sorry, where x is equal to 0 as well. So because this is the point that we're passing through, right? So this is 0, 0. So we're going to need to sub in 0 for x as well, right? So 0 minus p over, actually, sorry guys, I'll just rewrite the whole equation so you've got it here. So t of x is equal to x minus p over p plus 1 plus log e of p plus 1 minus 1. Now we know that both of these tangents pass through the point 0, 0, which means we're going to get 0 equals 0 minus p over p plus 1 plus log e of p plus 1 minus 1. So this is our first mark, identifying that. And then our second mark comes from evaluating this in CAS. So from CAS, we solve this and we get p equals negative 0.68 and p equals 5.31. And remember the question asks for correct 2 decimal places, so we need to make sure we do that. Which means that our p-value at this point here is going to be negative 0.68. So that's the point where it passes through the origin. And then when p equals 5.31, which is over here, the tangent again passes through that origin there. So between negative 0.68 and 5.31, the tangent is crossing the x-axis in this little section here. Anything less than negative 0.68, it's going to be steeper, it's going to pass through there. Anything more than 5.31, it's going to be less steep and it's going to pass through somewhere over here. Which means that our range of p values is from negative 0.68 to 5.31, and that's it. So it does include these sections because the question said where x is greater than or equal to 0, so we do include these. But that's it, so that's our second mark. Please hit me up if you have any questions about this. I know it's a bit weird. You might not have seen something like it before, but I actually really like it as a question. So let me know, but let's move on to part C otherwise. Part C is a 3-mark question, and what we're going to do with it is, first things first, C, 3 marks, awesome. So the question says, suppose P f of P is at a point P such that OP, the distance from origin O to point P, is at a minimum. Find the coordinates of point P when OP is at a minimum and state this minimum distance correct to 2 decimal places. Awesome. So what we're saying is we've got this point somewhere here, which is P, and this distance between O and P is at a minimum, right? So this is the minimum it can possibly be. So as soon as we see the word minimum, we're going to think we have to derive our distance, right? Because if we're looking for minimum distance, we derive our distance, let it equal 0. So firstly, we're going to actually have to find a formula for our distance. So we know that our first point is 0, 0, and our second point is P f of P, which is P log E of P plus 1 minus 1. Awesome. From here, we know that distance generally is equal to square root of x2 minus x1 squared plus y2 minus y1 squared, which means that we're going to take x2 as P, so we get P minus 0 squared plus log E of P plus 1 minus 1 minus 0 squared, and then we derive. So we know that this is our distance formula, and at the minimum, dp is equal to 0, right? Which means, according to CAS, we do have a CAS here, so we can use this. Please don't try and differentiate this by hand. It's just going to be super difficult. So therefore, 0 is equal to our dp, which according to CAS is log E of P plus 1 plus P squared plus P minus 1 over P plus 1 sort of square root of P squared plus log E of P plus 1 minus 1 squared. So massive mouthful, but this is our first mark, right? Getting that's our first mark. And yeah, so here, between here and this next part is our first mark. So now we just simply solve this in CAS, and this gives us 0.44 as a value for P, and those combined is sort of our first mark. So we know that our X value of our P point is 0.44. but we actually need to find the coordinates of point P. So we know that the x value is 0.44. We now need to find the y value based on that. So f of 0.44 is equal to log e of 0.44 plus 1, take away 1, and this gives us negative 0.63, which means that our p value, our p coordinate occurs at 0.44, negative 0.63, and this is our second mark. So we've stated the coordinates. Now what we need to do is actually find the minimum length, the minimum distance, right? Because it's told us to find the minimum distance as well. So d is equal to, according to our formula, 0.44 squared plus log e of 0.44 plus 1 minus 1 squared, which gives us a value of 0.77, which means that our minimum distance is equal to 0.77 units. Because we're talking about distance, we always have to use units, but we don't have any units, so we just say the word units. That's our third and final mark for MM240. Guys, please hit me up if you have any questions in the comments below. But otherwise, thanks for watching, and I'll see you in the next video.